Frustration. That's not a word you normally see up on a screen in a presentation. But I represent a small manufacturing company, and we suffer from frustration. You can say it's a personal problem, but let me explain to you. As a manufacturer, we found a problem with all CNC mills used in manufacturing. It affects every CNC mill using V-flange tooling. Now, we found the problem. We found the cause of the problem. We found the fix to the problem. But getting that message out to people has been very difficult. And therein lies our frustration. So I'm going to put it to you in a more universal term. Let's say that Toyota, engineers at Toyota, came forward and said something on the order of, we found a problem with all, in all cars with the spark plugs. There's a problem with the spark plugs. Now, if we make a change to the spark plug, you're going to have better performance in your vehicle, better gas mileage, lower emissions, and it's a simple change. It's not going to cost a lot of money to make this change. As a matter of fact, when you take your car in for a tune-up, your mechanic is just going to use these new spark plugs. You have options out there. You could buy an electric hybrid, sink $100,000 into an electric hybrid, or you can make this simple change in your spark plugs. And by the way, that simple change and the performance that you get from that simple change is guaranteed. So would you be interested? Wouldn't that get your attention? I think it would get mine. I think the first thing I would do is make an appointment and get my car fixed. So these are problems that are associated with every CNC mill that is running. And the problem is, because these problems are inherent, anyone who has ever done CNC milling has worked with these as part of their normal process. Vibration, chatter, poor finishes, all of these things, they all cost time. They all cost money. And they cost production. I keep reversing, I'm sorry. Let's take it down to a really basic level. If you have one mill and you're running only a single shift, so you're running a single 8-hour shift 5 days a week, and you have 30 tools, by making a small change in your tooling, you could actually increase the production on that machine to $20,000 a year, which doesn't sound like a lot. It really doesn't. But if you take that $20,000 and you apply it over 3,100 plus new mills that are brought into this country every year, that number grows to around $63 million. It still doesn't seem like a lot of money, but there are 570,000 mills that have been put into production in this country in the last 15 years that are actively producing. That number gets bigger and bigger every time you look at it. Now again, we're looking at one mill, 8 hours, 5 days a week with 30 tools. So consider a facility that is running 25 or 50 or 100 or 150 mills, and their carousels have upwards of 150 tools. And they're running 24/7. That number becomes a staggering amount of money that this country leaves behind. Now, one of the biggest savings that you'll find is in tool life. And the reason for this is that tooling flaw that caused all those problems is one of the biggest ones is vibration and chatter, and that just takes the edge off the tools. We ran an independent test, and you can review the testing parameters, but essentially in 2 setups, there was only one change, and that change was a change in the retention knob from a standard retention knob to a high torque retention knob. You can see the materials that were cut. Everything was identical except for that. And at the end of the day, what happened is that with the standard retention knob, that test failed. at 93.4 cubic inches of material. But with the high torque knob, it went on to almost 400 times the amount of material removed. Now you can say, okay, that's great tool extension, that's great tool life extension. But the reality of it is if you look at it from the terms of the material that was removed, that was 4 times the material removed without having to stop production to change your tools. That's significant. Now, if this was your car, you'd of course say, well, I drive a different car than was used in this test. I use different tires. I buy premium gasoline. Yes, you're going to see a difference depending on the material you use, on the tooling that you're using. But if you improve something, if you get rid of a problem, you're going to see improvement overall. And that's our point. There's a large medical device manufacturer that we worked with. They asked if they could remain anonymous, but they were losing business offshore. They actually just could not quote competitively enough. So we went in and examined a few things and found out that they did indeed have a tooling problem, and they also had some serious maintenance issues. We implemented a change that cost them $110,000 total. That $110,000 total had an immediate gain of 40% tool life overall. That means that some of their tools, all of the tools life improved, but some of them dramatically. What we also found is that if they played with that increase in tool life and they balanced it with their speeds and their feeds, they could increase their feed rates by 40%, which gave them 20% more parts on the floor, and they still maintained that added tool life of 15 to 25%, but they had an increase in production of $20.6 million that first year. And that is something that they will carry forward. That's not going to go away. They were going to fund new equipment, capital expenditures on new equipment and some specialized tooling. And they actually backed away from that and went into facilities expansion. Again, $110,000 change yielded $20.6 million in actual production. So you're going to ask me, what is the real problem? Well, the real problem is in V-flange tooling, you lose contact between the tool holder and the spindle. And it may sound like something minor, but that tooling was designed for 100% contact over the entire surface of the tool holder. As soon as you lose that contact, you lose production and you lose tooling life. Excuse me. There are things that cause that. There are things that cause that problem. But one of the things that you can look at if you want to find out if it's actually visible or you're actually experiencing it is a weird wear pattern on your tool holders. So even if you're not on the production floor, it's very easy to go onto the production floor and look for these signs. If there's a wear pattern at the very top, the thin portion of the tool holder, and a wear pattern at the bottom, and you see no wear in between, that means that 75% of that holder never made contact with the spindle, and that is a major problem. Again, that is going to create that whole list of problems that I showed earlier. So we designed this fixture, taper test fixture, and it mirrors the spindle. And what we did is we took a bunch of tool holders and we started testing them with this fixture. And we found that we didn't see growth in every single one of those holders, but the ones that did, it was a varying result, which adds to the problem because it adds to tool variability. What happens is once that lack of contact occurs, then you also open up the door for debris from milling, things like chips and coolant and oil, to filter onto the surface of the spindle. It's not going to happen evenly because the motion of that tool holder within the spindle is kind of random. But once that debris gets up into the spindle, you lose more contact. We found that the majority of the service calls that are generated on new machines are unnecessary, and they become very expensive. But if your tooling is not is not positioning correctly, if you're having the expansion, excuse me, if you have the expansion problems, then you're apt to spend. This is just a quick glance of expenses in Ohio. Just to have them show up at your door, it's going to be anywhere from $500 to $3,000. And if your problem has nothing to do with the machine, once that service tech leaves your door, chances are you're going to have even a larger problem. So we designed a complement of products, and these products are all designed to make sure that the spindle and the taper marry up correctly, that you have 100% contact. Once you have that 100% contact, then you have a reduction in vibration and chatter. You use less energy in your mill, and you have the potential to increase your speeds and feed rates and actually increase your production. It's a very easy system to implement. It's a very inexpensive system to implement, and it takes care of a whole list of problems, the vibration, the chatter. But on the other side of that, you're also going to see improved tolerances from improved tool rigidity. And that means you don't have the secondary and the secondary time finishing and polishing. It's either reduced or totally eliminated. You also don't have to constantly monitor what's going on, so your operators can move on. You can actually start moving into that lights out type of manufacturing. You have better tolerances, which reduce scrap. And because the tools locate consistently the same time, you have wear and tear on the spindle and machine reduced. And that cuts down on expensive maintenance time. Because you can increase your speeds and feeds, then you can meet your contracts without expensive overtime. And the need for custom tooling in order to make some of these really precision parts is actually eliminated. This tooling system was designed to be extremely accurate and extremely affordable. It was designed to create precision tools. And by making the slight tooling change, by making a slight change in how you install your tooling and how you maintain your spindle, you can return it to the way it was designed. At this point, I'm going to turn this back over to Janos, and he's going to describe how all the little points, all the little details do make a big difference in moving a company forward. You need that?
Thank you. Good afternoon, everybody. My name is JANOS. I'm president and owner of Delta Machine Company LLC. We are based out of Gardena, California, which is a South Bay area of Los Angeles. We specialize in difficult and very difficult precision parts, titanium and 5-axis machining, multi-axis turning. And a little bit about me, I'm from Hungary, Eastern Europe. I came here in 2000 with nothing, and my mother passed away a couple of years later, so we got stranded here with my brother. We went through a lot of hardship, and eventually I got into construction. Well, originally, I started programming when I was 8 years old, so I had a really strong programming background. I was very good in math and physics, but I couldn't apply it here. You know, you plan and life happens. And I got into construction, and when I was 25, basically I opened my first company. And it was going really well until the recession came and the market crashed and I lost everything. And basically in 2011, I became homeless. So the same year, I was looking for something else. And I got into CNC machining. I took a course how to program it. I realized with my programming background that was very, very simple. So I got into, I started working at Delta Machine. And basically from there, I learned very quickly the trade, and a couple of years later, the previous owner wanted to retire. He asked me if I want to buy the business. I said, yeah, I'm definitely interested. And that was probably one of the best decisions of my life. Well, when I bought the business, it had a couple of 30-years-old equipment, some mills, a couple of lathes, and you know, I was like, okay, how am I going to make this something different? I didn't want to just make a living. So I looked at how to change the whole thing, which actually today is a multi-million-dollar business, which we did in 2 years, less than 2 years, the growth. And one of my major things was that I looked at our business. I analyzed our business that, okay, what's our problem? We're doing precision parts, on a niche market. We did titanium, a lot of stainless steels, and really precise parts dealing with tenths. And we had no problem with that, but we were not making money. And so I started analyzing our customer bases. And I realized that our biggest problem is that we're very busy, but we're very busy with jobs that are not making money, or with customers who don't pay on time, and everything is a struggle. Then I looked at where is the market going. And that's actually one of the biggest problems I see with machine shops today and manufacturing and anywhere else, that people don't go with the flow. They think that whatever they're doing today is going to be still okay to do it in 5 years, 10 years. I mean, I talk with people who have been in the industry for 20, 30, 40 years, and they're like, you don't never even learn this trade. How can you do so well in it? How can you grow this fast? How can you do what you do? And that was one of the things that I realized, what is our capacity, what can we do, and how can we move forward from that? And I knew we do very precise parts, and that's a niche market. And mass production, we were doing tens of thousands parts, so it should have been easy to make money. And so I realized that the equipment we had was very old. We couldn't use it. So I was looking, what's the new trend? And I realized I got to figure something out how we can make what we're doing right now more efficient. And one of the things was that go 5-axis. And what that did is reduce setup times and we lost less accuracy on the part. And suddenly, when we started growing, I didn't get a 5-axis yet. First, I was looking at, okay, we have so much work. How can we grow? So I was thinking to open another shift. And I realized, okay, that's going to cost me another $20,000, $30,000 a month. How much is a machine that can work several shifts by itself? So I invested into automation, bought a horizontal cell, and that one is running 4 shifts a week, basically, because running 7 days a week, 24 hours a day. And I quickly realized that was a really good decision. And originally, because we were a small company, the banks were saying, are you crazy? You can't do it, you're too small, whatever, it doesn't make sense. But as soon after the first quarter, they said the numbers, we started to generate. Then they're like, oh my God, you can buy whatever you want. So after that, it was very easy to move forward. So because I started concentrating on what we're good at, and what I'm really good at is programming and titanium, so difficult parts. Like some of the parts we have down here, there's nothing flat on them. You can't really see on the picture, but it's ridiculously complex parts. But I like this stuff because this is the stuff I learned on, similar things that are already difficult, and I enjoy working on these parts. And what was really interesting, that when I started working more with titanium, the more titanium work came in. And I realized the aerospace is blowing up right now with titanium manufacturing, and they don't have enough people who can actually machine parts good. So this first part on the left, when one of our aerospace customers, they came to us and they asked me that, where are you going to bench this part? I'm like, we're not going to bench anything. And they're like, well, it's all surfacing. And I'm like, no, don't worry about it. When I take it off from the machine, you don't have to touch it. They didn't want to believe it until I delivered the first part. When I delivered the first part, the main inspector came out and started touching the part. And it's like, this is without benching? I'm like, yes. And how do you do it? I'm like, well, we use different techniques. And then we got so busy that I had to buy another horizontal. Then I bought a 5-axis machine. And it just became, once people started finding out what I can do, work was just started to come in. I mean, we're not advertising, we're not doing anything, and we're growing at an insane rate. And it's because we see where the market is, what we need to concentrate on. The problem is, like the first part, the competition, whoever was making it before us, their cycle time was over 19 hours. And they could make maybe 5, 6 parts a week. I did that part in less than 11 hours, and we could supply 30 parts a week, because we're running 24/7. So once they started becoming steady, then suddenly it became that they canceled other contract with other company and just gave everything to us. And that was the key when I realized that the biggest problem today, especially if you deal with aerospace, with Boeing or Airbus, is they don't care about the money as much as can you deliver enough parts fast enough on time and with good quality. These things are very important. And for us, it was very, fortunate that I really caught into the 5-axis machining very quick, and we can make really complicated parts. And it got to the point that I started testing out for different end mill manufacturers for titanium machining. And when they realized that I'm pushing their tools well beyond the limit what they can achieve in their own testing facilities, then they started to come in and ask questions that, how do you do that? How come your tool life is almost double of ours, and we have everything on our hand? And that was one of the things that I realized that a lot of people not doing is pay attention to every little thing. So earlier today, I heard a couple of really great presentations where everybody is talking about on the grand scale of things, that how you can optimize, and how you can make the whole chain work better. But nobody was really talking about that, okay, how can you make the manufacturing itself, just actually the making of parts, a little bit better and faster? And that's where it comes in that you have to concentrate on every little thing. And everything has almost the same importance. And that's where I came actually across JM Performance, who was making these special high torque retention knobs. But first very important thing is fixturing when you're doing machining. These parts you can see, these are without benching. This is the quality we get off the machine. The lower part is on the 787 Boeing, the engine mounts. And that's a forged titanium, and the quality and everything it's like almost like I don't know, something out of a dream, but it's actually, that's the quality that comes off the machines. I realized that programming is very important, how you approach the problems, because that part, to the company who I did work from, their cycle time was over 12 hours. And they were very proud of it until I told them I'd do it in 5 hours, 54 minutes. And then suddenly it's like, oh, how do you do that? And I'm like, well, I'm not going to tell you or something, but there's a lot of tricks to it. And some of the things that people underestimate in manufacturing, how important these key things are, like fixturing, programming, using the right method. Everybody thinks it's just the newest thing is the best. It's not true. What makes me very successful with the programs I run is I play with it. I do a lot of work and retry different things. I try the newest technologies. I try the newest tools. And now I'm in bed with most of the largest manufacturers doing constant tests for them. And I'm trying to help them develop together better tools for titanium machining, which is going to be one of the biggest thing in the future, I think, because it's becoming a larger part of aerospace. And it's becoming a very important part of our life today in medical and aerospace, military applications, soon probably in automotive and everywhere. So you need to be able to machine it. A lot of people are scared of it. I like it. For me, it's like I cut titanium almost as fast as aluminum. And that's the big difference, that I spent the time and invested in developing better ways to cut it, tried out different tools, different methods, how I can push. Another thing that was very interesting when I changed to these high torque retention knobs, what I saw is how much better our finish got and how much better tool life we got. So some of the end mills that we were getting 2.5 hour tool life in titanium suddenly went to 4.5, 5 hours. And that was one of the things that I used really the best holders, best hydraulic chucks. And I had from one of the manufacturers account rep in, actually an application engineer. He's like, what is different? We're using the same thing. You're using our holders. You're using everything the same, but your tools last longer. And the difference, what they didn't have, is the retention knobs. And it seems like a very small thing, but it makes a really huge difference. I can go faster, I can get a better finish, and my tool life lasts a lot longer, which basically costs my cost. When you're running long-term productions like we do, where you have 5, 10, 15-year contracts, pretty much you know how much it costs you. You can a little bit optimize over the years and save a little time, but the real cost in titanium is your tooling cost, because it's not like aluminum where you can cut with a tool forever. There's a certain amount of time. So by optimizing your tool life or increasing your tool life, you're saving money. And you have a choice pretty much that do you want to go faster and save cycle time, or do you want to just go a little bit slower and save tool life? So I analyze everything. I'm very analytical. I look at every little thing. I love to micromanage everything, which drives some people crazy at the shop, but that's their problem. I enjoy what I do, and it really helps us succeed that we concentrating on top edge. Like the equipment we have is running 24/7. We're going with the latest technologies, the best machines, because that's what sets us apart. And our growth, if you would look at it, it's like a hyperbole. It's insanely fast. Last year, we were 30% up. This year, we will be doubling our business, and it just keeps growing. And it's because everything we do, every company we deal with, they suddenly realize how beneficial it is for them also to deal with somebody who can understand these metal complex parts. Even look at it, sometimes customers bring easy parts, and I tell them, I don't want it. And they ask me why, because everybody wants that part. Everybody wants that job where it's easy and easy to make. There is no money in that. There is no challenge for me in that. And that was one of the important things that I wanted to set myself apart from everybody. I didn't want to follow everybody's method. And that's sometimes what people ask me, that how can you grow this fast? And as I was mentioning, because I never learned this in school or anything. I just picked it up and learned the tricks. And I was like, well, I'm not inside the box. I don't even know there is a box. So I really think different and approach problems different. And apparently it's working really well. And now it's getting to the point that much larger companies than us, that are like 100 times bigger, asking me if I can go in and teach their programmers, everybody, how they should approach their own product lines. And it's just very interesting how much we grew in such a short time and how we got to the head of the competition so quickly. So a little bit about one of the other things that's very important is light-side manufacturing and automation. I realized that early on that's the key for the future. And it's what I'm doing with my employees, because it becomes a big question, what are you going to do with the regular employees right now? You have to train them. You have to force them to go to school, learn how to fix a robot, learn how to program, learn how to set up, basically, because that's going to be the future. Everything else is going to be automation. And for the future goals for the industry is basically we want to be a flagship company in the titanium and 5-axis manufacturing, and growing a lot more, and actually helping people realize their own shop's potential. Because a lot of times I go to other shops and I see that they have been doing the same thing over a decade or a couple of decades or 40 years, and they don't want to change. And that's one of the things that you have to change. And as I heard so many things earlier today, that's exactly how I'm thinking, that you have to stay ahead of the curve. You have to realize that if you stand still, everything is going to pass by you. And then by the time you realize, it's going to be too late. So it's very important that you have to invest in yourself, in your company, in your people, and of course in your equipment and in your knowledge to advance in this era where pretty much the future is automation and super technology, everything. So I mean, that's in a nutshell. I think we have a few more minutes if somebody has questions. And yes?
So I have a couple of questions. My first one is, how do you approach strategic partners? Is that something that you have or have open to? And second is, how do you plan to scale your business?
Very good questions, especially, yes, I get approached by big companies now that see what our potential is, and they want to basically implement my method of thinking. And I'm open to it, but to a level that I don't want to, teach them every trick. I want to give them the ideas that they don't follow, basically, because the biggest problem is that most shops are going for the easy things. And when they face with difficulties or difficult parts or difficult materials, immediately they just back up and they can't do it or they take forever. And that's one of the things that I think everybody can improve. Even I do. I improve every day on everything we run. And your second question was, I'm sorry.
Yeah, how do you plan to scale?
Oh, to scale the business, yeah. So I think in 10 years, we're going to be probably 50 times the size we are right now, because right now we outgrew the place where we are in a year and a half, and now every time I buy a machine, even the machinery dealers ask me, where are you going to put it? Or something. I'm like, I play Tetris in the shop or something, move stuff around to fit more machines. But next year, we're going to go to a growth and more, and we have to buy a much bigger building and move on. And once we fill that up, then we grow up. I mean, you know, people say, what's enough? And I think there is no such thing as what's enough. It's like how long you are excited about what you're doing, and do you have bigger goals where you can actually dream big? And you know, I came here with nothing. I was homeless a few years ago, and now I own a multi-million-dollar company, which is growing. And it's pretty much the American dream, that you can achieve anything here if you work hard and you know, you put a lot of effort into it. Anyway, anybody else? Yes, ma'am. Yes, we run aluminum. Like the top part is actually an aluminum bracket. It's on a Predator drones, and there we can go faster, a lot faster. I mean, actually, I pushed so fast that we have coolant chillers on every machine because of the titanium. When I was cutting that, the guys from the coolant chiller company, they were asking that, what are you doing? Because the coolant temperature went from 63 to 87 in 30 minutes. So they say, what is it? Because I can push so much harder the materials that actually everything just heats up. So you have to actually cool it. But yes, the finish is amazing what you can get with it. I have other machines, a couple which don't have, and I cannot achieve finishes like this. And the tool life is crazy. I mean, I ran 40 parts. Each of these parts takes about 9 hours to make. It's a pretty big aluminum bracket. It's, you know, I never changed the tool yet, and we ran about 40 parts already. Anybody else has any questions? All right, so I think we're done. Thank you for your time.